Hey guys, I'm going to run through the clickers for Chapter 3 because some students were not able to make it today because of Veterans Day events and because people were sick. Anyway, so I'm going to go through all the clickers. You're going to want to pause this, okay? Because I'm going to show the question and then give you like a very quick countdown and then go to the answer. And if the answer is not fairly self-evident, I'll spend a little time explaining it. But yeah, plan on pausing these because I'm not going to give you enough time to think about them. All right, so let's start off here. So this is the first one. Given vectors p and q, what is p plus q? And I'm going to change the answer in 3, 2, 1, and there's your answer. And it does show you how to set up the vector diagram. Basically, you're adding vector p plus vector q, and the resultant is this one down here. Okay, next question. Which vector is this in the second row shows vector a plus vector 3? Here we go in 3, 2, 1. There's the answer. Same kind of idea as before. Here's the next question. Given vectors p and q, what is p minus q? Counting it down, 3, 2, 1, and there's the answer. Now, the way we do this is you can go head to head, which is let's see, actually they do it the negative q. This is the way I do it. So it's p minus q. So the way I like to do it is p plus negative q. So this down here is negative q. You just go tail to head like normal, and your resultant is over there just like before. Okay, next one. 2a minus b, so we actually get to multiply a vector, but I think you'll figure out how to do this. Here's the answer in 3, 2, 1. There it is, and it explains it pretty well. Next question, question 5. Now this is showing acceleration. So a particle undergoes acceleration. I'm going to move myself around a little bit here. This will probably be better. The green arrows in these slides represent acceleration. So this is the velocity that's given, and then during that time, it experienced this acceleration. And what they're asking you is to find the resulting velocity because of those. And here's the answer in 3, 2, 1. I didn't do it. Let's try that one. There we go. There's the answer. And I think you can figure that one out, puzzle that out from what it's saying. Okay, here's question number 6. Diagram shows 3 points of a motion diagram, and they want you to find the acceleration during this trip, the acceleration at the moment that it was at point 2. Answer in 3, 2, 1. There it is. This is kind of the idea of centripetal acceleration. So this is as if the points are going around some central center of a circle, and centripetal acceleration says the acceleration is always toward the center of the circle. So that's what it's showing. Next one. X and Y components of this vector. You can just look at the grid to figure it out. Answer in 3, 2, 1. There it is. Hopefully that's not surprising. The convention here is that they list the X component first and then the Y component. Question 8 is this one. Same as before. Same as question 7. Here's the answer in 3, 2, 1. There it is. Again, hopefully that shouldn't be too surprising. Question 9. All right, so this time it's a little bit different because the vector is not starting at the origin, so that makes it slightly more complicated. But they're talking about the X and Y components in reference to the vector itself. Okay, and here's the answer in 3, 2, 1. That's it. Question 10. This looks a little dense. It's asking whether you take absolute values for these components or not, and then which order you put them in. The Y first and then the X, or the X first and then the Y. Use SOHCAHTOA if you're not sure how to do this one. I'll reveal the answer here in 3, 2, 1. There it is. Okay, and again, SOHCAHTOA will do this. So SOHCAHTOA, SOHCAHTOA. And you can figure it out from there. And by the way, all this information is also available on the AP Gouge. They don't write it as SOHCAHTOA, but they have all the diagrams so you can figure this stuff out. Okay, question number 11. Here we are. Following vector has a length of 4 units, and they want to know the X and Y components. Okay, here's the answer in 3, 2, 1. And there it is. Now, this is a classic type of AP question because if you want to get out your calculator and solve it, you can, and you will come up with these answers. However, if you pay attention, you'll see that all of these, the magnitudes of all of these are the same. So you can assume that they've worked out the magnitudes for you. So it's 30 degrees. You know that the horizontal is shorter than the vertical, and you know the horizontal is negative. So you look for the small negative and the big positive, and you jump straight to the answer, and you don't have to mess with trig. Okay, so look for that. A lot of students see the problem, and before they peek at the answers, they do the math to find the answer. But College Board loves to give you questions where you don't have to do the math. It's to tell the difference between students who are paying attention and students that are just mindlessly grinding through the math. Okay, so question number 12 now. Um, Same idea. They give you the magnitude and the direction, and they want you to figure out the components. Answer in 3, 2, 1. There it is. If you want to practice SOHCAHTOA to get these answers, good on you, more power to you. But understand you don't have to do trig to answer this question. Okay, 13. AX is the blank of vector AX, and this is really a terminology thing. The difference between this symbol and this symbol is that this one has a little arrow over it, and that little arrow over it means they're talking about a vector quantity. And if there is no uh, no arrow over it, then they're talking about a scalar quantity. So that's the hint. Here's the answer in 3, 2, 1. There it is. It's the magnitude. Because this is magnitude in no direction. This is magnitude and direction. All right, this is getting into motion on a ramp, asking about the acceleration of the ball on the ramp. Here's the reveal in 3, 2, 1. There it is. It's constant negative acceleration. Even when it's moving up the slope, it's slowing down, which is a negative acceleration. Then when it runs out of steam and starts rolling backwards again, it's still a negative acceleration, or an acceleration in the negative direction. So that's why it's a constant negative acceleration. Now, it does stop for a moment at the top, at the apex, but that is an infinitely short moment. So this E is not the correct answer. It's not that the acceleration stops when it stops. It's a continuous acceleration. Okay, question 15. We're making progress here. This is a relative motion question. AP doesn't care about these anymore, but this one isn't too hard, so see if you can get it. Here's the answer in 3, 2, 1. There it is. All right, and it turns out to be a 3, 4, 5 right triangle, so you might not even have to do Pythagoras in that one. All right, next question, number 16. Heavy red ball is released from rest on a flat horizontal surface and so on. I'll let you read it. Give you the answer here in 3, 2, 1. There it is. This is the demo of dropping the ball and launching the ball horizontally at the same time. They hit the ground at the same time. Question 17. I'll let you read this one. 100-gram ball and a 200-gram ball roll off the same table at the same speed, and they want to know what the landing distance is. Here's the answer in 3, 2, 1. There it is. It's the same for both because all objects fall downward at the same rate. The 100-gram ball will fall at the same rate as the 200-gram ball. G is G. So they take the same amount of time to hit the ground, so they go the same distance. Question 18, about launching projectiles at steep angle or low angle. I want to know which one hits the ground first. Look at it and think about it. And here's the answer in 3, 2, 1. It has a lower trajectory, so it doesn't go as high, so it doesn't stay in the air for as long. So it takes less time to hit the ground. Question 19, about a car going around a curve. Is it accelerating or not? Here's the answer in 3, 2, 1. Yes, it's accelerating because acceleration is the change in velocity, and velocity is speed and direction. So if the direction is changing, velocity is changing, it's accelerating. This one asks the same sort of thing, but it's asking about the direction of the acceleration. And it might be if the acceleration is 0. Hopefully you know it's not 0. Here's the answer in 3, 2, 1. There it is. This is a centripetal acceleration. The acceleration is toward the center of the circle that it's going around. Let's see. We're getting close to the end here. Okay, toy car, circular track at constant speed. Oh yeah, ask if what happens when you change a variable here. Suddenly doubles its speed. What happens to the acceleration? And here's the answer in 3, 2, 1. There it is. There's the answer. Okay, I believe that's the end of it. Yep, that's it. That's all of them. Okay, hope this is helpful for you. Again, if you were absent, you can get this review. This is pretty much all we did. And we were catching up on late work. So, yeah, that's it. Good luck. Hope the Veterans Day concerts went well, if that's where you were. And we will see you next time.